So we have given a very good start with a very high volume presentation by two of the speakers on EV space. We have talked about how great potential lies ahead for EV, but it is also that every potential or opportunity has to go through uh, myriads of challenges. Uh, and that's what the panel is about. What are the challenges and opportunity that we will debate with our entire ecosystem that we have? We are lucky to have policymakers. We are lucky to have system provider, suppliers, and as well as OEM at this panel. So before we go into the discussion, I would like to invite uh, Jitendra Goyal ji to come and give an overview of the challenges or the opportunity that we see around electric vehicle. Jitendra ji is leading the R&D at Toyota Kirloskar Motor, and we are aware how Toyota is trying to explore multiple sustainable mobility options. So none other than him could be the best person to give a balanced view on the challenges and opportunity in this space. Jitendra ji, please.
Yes, good evening, everyone. It's my pleasure to be there here, and thanks, Nabeel. He keep on challenging us to make the presentation every time. So let me go to my presentation about opportunities and challenges. So I'm going to cover about what are the opportunities and challenges are there in developing the EV ecosystem. So we all know very well that we are having energy security, pollution, global warming issue everywhere. It is not only in India, it may be very severe, but the challenges are same worldwide. And the what is the fundamental response globally is taken is that for these issues addressal, vehicle electrification is necessary. There is no other way. But vehicle electrification means that we have to expand it to everyone. It cannot be only for the niche segment. And second point is we have to make a product which is acceptable to the customer. Customer is king. We cannot make the product of what we want to sell, but what customer can buy, that is very important. Seeing India condition not different because you have seen this many times that how is our fuel imports, pollution, CO2 reduction. But another thing which we should not forget that India's manufacturing leadership. We have to create the job and automobile industry and manufacturing 16% is the our share, and we want to increase and 100 million new jobs we have to create. So we cannot ignore that part of the India. Of course, there is a good response from the government side. Lot of initiatives taken, like public transport. There is a FAME 2 scheme. Important thing is currently our electricity produces 70 to 80% from coal. So we have to go towards the renewable energy to make really electrification more environment friendly. And government has taken target in 30. We want to target 40% renewable energy. I think that is very important. And everyone knows that 50% of the vehicle cost is battery, 50%. And that time we can't shift from crude import to battery import. It is very much important we go for make in India. And I think government has taken that and planning to set up 50 gigawatt plant with the huge investment. So important point is that EV is must, but the most important thing is it should be make in India. So Indian automotive industry is a very, very potential industry, and we have a big contribution for the Indian economy. 49% of the manufacturing GDP comes from India, and 7.2% of total GDP comes from the automotive industry. And not only OEM, but component industry also play a very big role. And if you can see the exports, we have 90,000 crore exports from India. We cannot ignore automotive industry. We cannot ignore component industry. And if you see what is the current condition on what it is, auto industry is there. Currently, we are selling 99.9% vehicle are ICE. Revenue is coming 50% from conventional vehicles, conventional engines. Employment 60%, export 45%, and already there is a huge investment made in the BS6. So we cannot ignore that fact. So from that point of view, definitely electrification is must. We must move for the EV. what is required for making the ecosystem, understanding the challenges is very, very important. Currently, we have 69,000 fuel station, whereas EV, we are still catching up 1,000 EV charging station. Similarly, service station, business model, component manufacturing, product development and testing, recycling, all are these areas which we must set up. And these are the new areas which are cannot be copied from ICE, but we must set up. And these are the challenges are very, very much important to set up EV ecosystem. Another thing, if you see the battery localization status, China and US is having from end-to-end localization from raw material to pack manufacturing. Whereas in India, currently we are only doing pack manufacturing, still we have to do the localization. So that's why it is important to do the localization, and we need volume for localization. So this is very important, that till that time we have the volume, localization is not possible, but and cost cannot come down, customer will not buy, and it become egg and chicken story. We need volume, then only cost will come down, customer will buy, but customer will buy when there is a low cost. So we must address this situation, and we must go ahead to how to do the localization. So if you see, this is a vicious circle where low EV sales, low EV demand, no investment viability. Why there are no manufacturing is starting? That is because viability is not there, because business needs viability. So EV volume must be increased. That is the most important point for India. Then only we can go for the electrification very quickly. So for doing that, important thing is we must use current ICE supply chain. We cannot ignore, ICE is not going to die. We cannot ignore current ICE supply chain. We must use it. We must develop EV core component industry, battery, motor, and inverter. This is the core component. We must develop that industry. We must do the localization. Then only we go for the affordable EVs. We must increase electrified vehicle penetration, at the same time keeping the ICE, and we must accumulate volume for the early localization. So these are the requirements for the Indian condition to go towards the electrification or to go towards the EV. Just for your information, that what is the electrification means. Electrification has different technologies, many technology. One is the hybrid electric vehicle, which use the same electric motor, battery and inverter, but with engine. It is hybrid electric vehicle which keep on charging on board, and the engine is also supports, and it works on the electric vehicle also. Another is the plug-in hybrid electric vehicle which has external charging, is the additional point. Battery electric vehicle which has these components plus charging, and then fuel cell electric vehicle where the charging happen on board using the hydrogen. So these are all the electrification technology which is available, which we must utilize. So most important thing is diversification is needed. We can't have only one technology suitable for all the markets, all the customers. If you can see in the chart, personal mobility, as mentioned by before Mahesh Babuji also, for the small vehicles like two-wheelers, three-wheelers, small car, yes, battery electric vehicle is what is suitable for running within the city. But when we go to the bigger cars, passenger cars, we have to think for the different technology where we can give the range to the customer. We can give them the affordability to the customer. From that point of view, we have to think about the other solution like hybrid electric vehicle or plug-in hybrid. But when it goes to the buses and trucks, we have to think further another technology, which is the fuel cell electric vehicle, where on board through hydrogen, you can charge the battery and you can run the vehicle by using the hydrogen, and which is easy to transport instead of carrying half weight of the vehicle in the battery. So these are the different technologies suitable for the different kind of segment. So just let me introduce about the technologies, that what are the technologies. Hybrid electric vehicle, it uses the same component as EV, but it works on 600 volt. It works only EV drive only mode, and the fuel efficiency increase is almost 45%, more than 45% compared to ICE. So hybrid electric vehicle, this is the diagram. So this is the technical thing, that how it is arranged in the hybrid electric vehicle. It uses the same component. Just let me take you through this video for your easy understanding that how really hybrid electric vehicle works.
engine and motor. Then this system combines these with the power split device to achieve high energy efficiency. This is the Toyota hybrid system. Each unit has been developed specially for the hybrid system. For the engine, the maximum thermal efficiency has been raised and both low fuel consumption and low emissions achieved. The motor is compact and high efficiency to achieve smooth acceleration. The generator uses the engine rotation to generate electricity, which is sent to the motor and the drive batteries. It is also used as the engine starter and provides smooth engine starting. The power split device contained in the transaxle is Toyota hybrid core technology that divides the energy output from the engine between electrical generation and driving according to the driving conditions. The power control unit is the core of the hybrid system. It controls the electricity to provide appropriate amount to each unit. The drive batteries store the generated electricity and supply it to the motor to drive the vehicle. There is no need to recharge from an outside power source or to replace the batteries periodically. They also provide superior durability and heat resistance. Toyota hybrid units have the reliability made possible by years and years of design development and continuous progress. For a Toyota hybrid vehicle, when not moving, all units stop and there is no wasted energy consumption. When the vehicle starts off, the motor drives it quietly and smoothly. For driving at low speed, the motor is used to achieve low fuel consumption. During acceleration, motor drive is combined with engine drive in a rotation range with good engine efficiency to drive the vehicle powerfully, yet with low fuel consumption. The engine drives the vehicle and charges the batteries at the same time to raise the energy efficiency. During deceleration, the rotation of the tires drives the motor to generate electricity to store the power into the batteries for reuse. In this way, a Toyota hybrid vehicle.
So basically, if you see that in the presentation also, this is the upper portion is showing that whatever you are seeing the orange when engine is switch on, and blue portion is vehicle is running. So when even the vehicle is running, engine is not getting on, and even idle condition engine is not getting on. So 60% of the time it runs on the EV mode. So that's why the fuel efficiency, there is a high fuel efficiency we can get. So the benefits are there that when we combine this with ICE and electrification, we can get high fuel efficiency, lower emissions, power and quietness, everything we can get which is acceptable by the customer also. And it doesn't need outside charging. So this is a low hanging fruit which can be implemented immediately. And we can do the localization of components also. So this is the currently we are having Camry hybrid. So Camry hybrid, which is a large size car, the fuel efficiency is 23 kilometer per liter compared to its conventional. It is more than 50% efficient, and the CO2 emissions and the emissions are 1/10 of the BS6 target. So that's why we can make these kind of environment friendly. We can immediately introduce this technology. So important thing is this hybrid technology. Hybrid electric vehicle technology, it makes all EV, PHEV and FCV. All the core is there in the hybrid electric vehicle technology. So you can see in the battery electric vehicle, if you make the battery size bigger and we charge from the outside, it becomes battery electric vehicle. Similarly, this is the vehicle which we designed 6 years before, battery electric vehicle, where we use the hybrid electric vehicle parts, and we made this EV, which we are running now for R&D purpose. And similarly, fuel cell electric vehicle also, by adding the fuel cell stack there, we are making it able to make fuel cell electric vehicle. So just by addition in the hybrid electric vehicle, we can convert it into the different technology. So this is the Mirai, how Mirai is made by adding the FCV and using the same components of the hybrid electric vehicle. So each technology has got its advantages, merits and demerits. It may be on the economy point of view, there are advantages when it comes to HEV. Local pollution, definitely BEV's advantages. We have to select the right choice based on the customer, based on the market situation, based on the country condition. And by doing electrification, if you see that as previously told, 30% is the target by 2030 Niti Aayog report, that EV is 30%. But even the 70% of ICE we convert into the electrification. In that case, we can achieve, currently with the 30% BEV only, we can achieve 132,000 crore fuel saving. But if we do complete 100% electrification, we can achieve 350,000 crore fuel saving. So that's why it is important to adopt all technology, promote all technology, so that we can achieve in the faster pace, we can achieve the localization and we can achieve the national objective. Similarly, for the, because BEV has very less component, but from the employment point of view, it is very important that we keep all the technology. And core component also we can increase, because 10.5 million vehicles is presently planned to sell in 2030. If we make all XCVs, then we can make so many components and easily we can localize. If we talk global perspective, globally also, if you see, all technologies are promoted. Similarly, this is the Japan case study, where after they promoted the hybrid electric vehicle and other electric vehicle, the current ratio is 33% and they could reduce the CO2 in Japan. Similarly, China example, China was giving big subsidy on the battery electric vehicle. From this year, it is reduced. Suddenly, their volume came down. So important thing is we have to make it affordable. Only by subsidy, it is difficult. So localization and making it affordable is very important. There are some good policies, like in the Thailand, it is their CO2 based taxation. These are the ways in which we can think in future, where really based on the performance, if the benefits are given, customer will also buy. So basically, what we think that it is important to create the demand for local manufacturing system and to develop the EV eco components, and it must be made affordable. It must be made in India. So that is what we want to. That is what we want to propose. So thank you very much for your patient hearing. So I hand over to Nabeel.
Thank you, Jitendra ji, for bringing this complete twist to this story. And now you are saying that there are perils of complete movement to EV, and that's a job, obviously. And the other thing is that do we have that kind of power generation, or from a cleaner means, because we have mostly fossil fuel. I would like to come to you, Mr. Shashidhar ji. You are one of the states which has been early adopter of EV. We talk about electrification. Jitendra ji raised the question of are we really going green? Are we really going to clean up the pollution mess that we have when we are producing larger part of electricity through fossil fuel? Not only this, I also want to understand that at which pace we are increasing the generation of power in India. If you look at the pace at which we expect electrification to catch up, how are you trying to match the gap that is going to be there in this space?
Thank you very much for the best question, which I love from deep from my heart. Okay, let me start with Karnataka's legacy in terms of power generation. It was 1902, the first 42 megawatt hydro power station before in entire Asia that we could able to put up in Shiva Samudram, and which was supplied to 25 cycles to Taylor company in KGF for gold mining actually, and subsequently which was the first transmission line, longest distance at that point of time was laid here. And 2009, it was 3 megawatt solar power plant that was commissioned by Karnataka Power Corporation Limited, state-owned generation company near Kolar, Elesandra. Okay, there was a megawatt scale. Purulia in West Bengal was there; it was 1 megawatt, but there was no much advertisement or publicity was given on this 3 megawatt, which was done at a capex of 19.5 crore. With almost 16 to 18 rupees per kilowatt hour to a 2000 megawatt in a contiguous of 14,000 acres of land in Pavagada. Today we are really proud of it, having kind of tariffs ranging from 2.4 to, imagine the way, the kind of drastic changes. I really would like to compare the scenario of that. Even the capex has been substantially dropped from 19.5 to 4.5 to 5 today on solar module the installation on capex perspective. So I could see a similar scenario for EVs also on a very short term. We're going by my gut feeling that Indians are highly adaptive, and we know the jugaad innovation can also happen. And I think I can say the Pandora box is yet to open. Okay, coming to this point of electricity, okay, the abundance or how much that we can able to cater. 28.5 gigawatt of Karnataka's installed capacity today, having 14 to 16% exclusively from renewable energy, including that 2000 megawatt, and about 104 talukas are having 20 megawatt solar power already installed in Karnataka, apart from 300, 500 scattered across Karnataka. And we have one of the best renewables achieved very long back, and because of that, our regulator, Karnataka Electricity Regulatory Commission, has categorically said all electric supply companies not to buy any no more EV, no more renewable energy purchase, because you have already classed your obligation, renewable purchase obligation, called RPO. So looking at that point, now what we are really seeing is not the question of how much quantity. What we are seeing is the kind of how to maintain the kind of grid and its effectiveness of grid management, and what is the effect of putting up of these EV charging stations across Bangalore first and Mysore and then across state. Bangalore Electric Supply Company has been nominated as the state nodal agency not only for its geographical area but also entire Karnataka. So about 100 EV charging stations are already about to get completed, and about 6 are already in operation. Another 650, we have Bescom has sent an expression of interest to Department of Heavy Industries. It's likely getting approved out of 1000 that they called for. But what I could see is today we are talking about a one charging station in a grid of 3 by 3 kilometer. Tomorrow it may be within 1.5 kilometer. And what I could see the possibility here is how to assess the kind of impact on the grid management, a futuristic battery storage system, and many other things. In that context, 25th February of this year, we had a chance to have one workshop with foreign Commonwealth organizations arranged in collaboration with the UK Deputy High Commissioner Bangalore, Catapult, and many other UK companies were here, and they were very keen in associating with us in finding out the futuristic plans for Karnataka and extrapolate it to India. So that's it for now.
You talked about solar power, but the storage is a big problem when it comes to solar power. Do you see any kind of breakthrough in that direction?
When I talk solar, it's all real time. Today, when you go to the technical perspective of having a one graph of our peak shortage in terms of usage, during our peaks would be very very steep. Because of these solar plants, our peaks have been shaved, almost halved. That means the comfort level in terms of grid management today, and we are not stressed, and we don't have to stress our coal-based plants particularly, and we have one of the best hydropowers that are in reserve, and it used to be termed as the shock absorber of the southern electricity grid. Earlier it was asynchronous in those days. Now it is through 765 kV lines. The entire India is one grid. It's been done already. So that means we have more flexibility in terms of even to the Bhutan, Bangladesh, inter country lines are also being laid. And the kind of potential that we have today is not the question of quantity of power, but the kind of the technical management, optimum utilization, and especially when I said 104 taluks having 20 megawatt, grid connected solar generating plants. That is something very advantageous in our system. And B, in future also we would like to go for electrification of more than 20 lakh irrigation pump sets. I'm looking forward. Just now we mentioned Jugaad innovation. I don't know what's going to happen out of 20 lakh irrigation pump sets.
Let's hope for another jugaad coming up. I'd like to bring you here, Anil ji. The other point that Jitendra ji raised is of jobs and localization. How do you see the system suppliers? Because he talked about the suppliers. I think they are contributor in terms of jobs. They contribute almost 5 million jobs in India. Auto component makers. You are a component maker. How do you see your community evolving to match up the change, transition, and save the jobs of the people?
Yep. Nabeel, I will just step a little back into the climate first and then come into the ecosystem for the supplier side, because there is a link between both here. When you look from the pure climatic point of view, right, I would just like to state an example, of course, which will support what Jitendra just mentioned. Just take an energy mix of 60% coal and 40% renewable. And this is out of a case study made in Germany, but of course applicable very much in India. And you take a 1.4 liter engine car. If it is a diesel vehicle, from well to wheel, that's what we describe in terms of the amount of CO2 expended. For a diesel car, it expends 140 grams per kilometer. For a gasoline one, it goes to 147 grams per kilometer. Surprise, an EV goes to 148. So, is EV the right solution with this energy mix for this class of vehicle? Not. Is it the end of the road? Really not. So, if you just look at the hybrid now, if you put a hybrid for a gasoline or a diesel, it comes down by 15% of the CO2. Of course, there are different types of hybrids. I wouldn't like to go more technical into this topic. I'm just looking at a P0 configuration hybrid. It comes to 120 grams per kilometer. So what I mean to say here is, the ideal solution, the true north, is EV, no doubt about it. But we'll have to watch a bit about what is the premises on which EV is really emission free. It's not that we shift the problem from the exhaust to the chimneys. That's not the idea here. So coming back to this, why I made the statement now. The statement is, there will be a coexistence of technologies. ICE is not going to disappear overnight. And it is a transition till the premises are clean for EV. And this will take some time. And till such time, we need to see that the ICEs are well optimized. And how do we do it? By controlling the CO2. And technologies are different. So as a supplier base, now I come to the question that you addressed me. As far as the supplier is concerned, it is the job of the supplier base to support the automotive industry in the transition to clean energy. That's the description I would make. What does it mean? Our estimates go that even by 2025, 80 to 85% would still remain ICE. And of course, that 15% to 20% itself is a massive transition into EV. So this transition, the supplier base can gear up. I come to the other point from the climatic point of view. Let's take cradle to grave situation. What I mean by cradle to grave is you put in everything that is expended, including manufacturing and disposal of the elements, and see the total CO2 emission. If you take even this, 1 kilowatt hour of battery consumes 100 to 150 kgs of CO2. Imagine now if we use tons of batteries. And imagine that we just go for a normal car of 30 to 40 kilowatt hour of battery. You start with a mortgage of a huge amount of CO2 that is already expended. In order to catch up with the mortgage, it would take almost 10 to 12 years for personal mobility. For fleet mobility, it is lesser. So now I come from the other side to say the immediate electrification potential is certainly for the fleets. But when you come down into the smaller light electromobilities, it is also surprising to note, be it the well to wheel or cradle to grave, the business case is very, very positive. And that's what Mahendra Babu was talking about, that the best business case for countries like India, where the last mile makes a huge difference, it is the best thing to do with electrification of three-wheelers and two-wheelers. This will start the momentum of the supplier base to start getting into electrification. Because electrification is a journey of learning. The competence will have to change significantly. The skill sets will have to change significantly. So this is a learning ground for us that we start into electrification of the mass mobility of three-wheelers. It's got a potential of almost 700,000 per year. It's a great volume to have. And then as we do this, two-wheelers will catch up. And the volumes of two-wheelers is in millions. So while we do this, automatically the transition of the supplier base is happening now from the ICE conventional into electrification. And as this progresses and while the energy gets more cleaner, we migrate into the different levels of pass cars. So I'm quite optimistic that the supplier base in India is fully capable of handling this transition. So the first, if I just look at the two-wheelers and three-wheelers, the number of supplier base that is building up is tremendous. And I'm sure the FAME 2, when April 1st of 2020 we gets into SOP, we have enough and more of capacity that's being built up. But a lot of work has to be done, competence to be built, electronic competence particularly, the gap has to be closed, but I'm sure we will catch it up.
Okay, but you are advocating that we should look at some midway like hybrid. But I would say that even plug-in hybrids and all cannot completely do away with the well-to-wheel and the argument that you are giving that we are merely shifting the place of emission or pollution. But that exists even in plug-in hybrids and other options
Yeah,
that
just
you are
Nabeel, I
talking
would just
about.
like to clarify this point so that we are clear on the same page. The plug-in hybrid requires power. I'm talking about the P0 hybrid, which does not require power, and that's also what Jitendra told. So hybrids which does not take the power from outside are the ones that will be beneficial to the environment till the energy mix is clean. So there we have a tremendous improvement on the CO2 and the fuel economy of the cars.
But looking at the driving conditions, I have driven hybrid car in India. I went in a hybrid like Lexus hybrid. So in city, I was able to use that hybrid, but when you are on highway, it's very difficult. Very less of the time you use hybrid. So we have to see that there are rider there also. We cannot completely, go with that. Hybrid is the best option right now. Coming back to you, Jitendra ji, recently IEA has come out with a study which says that whatever we are able to save in terms of emission or whatever pollution we are able to reduce by way of implementing electric vehicle is already being compensated, or the amount of emission and pollution is coming because of the over popularization of SUV around the world. How do you see this changing as a product and development head?
Yeah. First, I want to address your Lexus issue because that is also from Toyota. So let me tell you that hybrids, when it comes to the traffic condition, it performs better. The fuel efficiency far better because in the idle condition, engine doesn't switch on, and most of the time it runs on EV mode. That's what I showed in the graph. 60% of the time it runs.
But when you go beyond 65 or 70 kmph on the highway where you are to reach faster, your hybrid doesn't work.
It works. It will be still giving you 45 to 50% fuel efficiency. And when you are cruising at 80, 90, that time also it runs on EV mode many times. So I think once you come to TKM, I will take you to with the hybrids
I
on the
have
test
driven it
track.
for 2000 kilometers. So I went from Delhi to Patna
I see.
on Lexus just to understand this, if it is, how it is.
Okay. Let's continue that discussion. And coming to your next point about the SUVs, definitely, as I told you, customer is king. And especially Indian customers are very, very sensitive with the external, look, they want a mature vehicle. So currently you see that the compact SUV market is developing very fast. But that is a misnomer that if it is a compact SUV, it cannot be efficient. Still, we can make efficient fuel efficient compact SUVs also. So when it comes to design, definitely we have to keep customer in mind, but at the same time, powertrain point of view, we have to be very, very aware that how to improve the powertrain so that we can make the energy efficient vehicles. So yes, we have to keep the balance of that.
Mr. Yamamoto, you are working in thermal management space. With electric vehicle coming in, that is very important for the longevity of the battery, which is the highest cost. What are the key technological upgradation or innovation that you see there that could help in conditions like India, where you have varied temperature, varied climate situations?
Yeah, so our company working on the thermal systems, two-wheeler, three-wheeler, and four-wheeler also. Yeah, most challenge is the four-wheeler. So yeah, as Mr. Chako also explained, thermal management system is a very important element to have a very efficient and also long life battery for four-wheeler especially. So what is the challenge is so system, total thermal system not optimized yet, even developing country. So especially in India, so yeah, surprising heating is something deteriorating efficiency. So maybe you are thinking you are not using a heating, but time to time you are using a heating also. Yeah, to control the humidity and also to control the best temperature. Yeah, if you turn on the AC switch always max cold, at that time you are only using a cooling. But if you try to adjust the temperature, heating will start using. So this is one of the challenge. In fact, EV, you need to manage battery and the air conditioning and the traction motor and also so power electronics inverter. So then, so everything normally managed by should be managed by one system to optimize, especially battery cooling, heating, and also air conditioning. Typically, one compressor managing this thermal system. So then, so this is not so easy to optimize. So this is a challenging point. So I checked the patent more than 500, but this is no real optimized system found, especially for India. So I'm reading this development in India. So in India, you have a rich resource, engineering resource, lacking a little bit experience. But you have a quite capable engineering base. But another challenge is a component. So to optimize the system, if it is a new, you need to develop a new component also. Heat exchanger we can develop by ourselves in India. But still some of the small control component, so this is quite difficult to find in India. So that's why so we are working with Robert Shaw, so Mr. Chako on this point. So this kind of all the components also we should localize, develop, manufacture in India. So this is we are facing in India.
Thank you so much. Before I go to the audience, I'll have one more question from you, Mr. Shashidhar. Last time, one of the official from Karnataka government, she announced that Karnataka is working on developing an EV ecosystem around Bangalore. How is that progressing? Where is it right now?
Our state is the first one who announced this electric vehicle and energy storage policy back in 2017. Immediately after that, actually, this policy was a result of consultative meetings, a couple of dozens of consultative meetings held by the industry body, not from our side. We are just facilitator. Immediately after that, we issued the operative guidelines, and today I'm very proud to say that the first EV summit happened on 30th of January across the globe. 15 companies from South Korea, about 5 companies from very core companies from Taiwan, Japan. They participated in Bangalore, and then on 30th May, we started a stakeholder meeting under the chairmanship of Principal Secretary Commerce and Industries, and we asked and requested the bodies or the leaders of the industries, including Toyota, to lead some 4 technical committees. They are R&D, innovation, skill development, and the common testing facility and cluster development and formation. So they volunteered, and so Toyota is in 2 3 technical committees, and Mahindra, Mr. Mahesh Babu is heading this cluster committee, and SECRI, Central Electrochemical Research Institute, Karaikudi, under CSIR, Mr. Dr. Kulbir Singh, he is leading R&D technology. So what happened? More than 3 to 4 such meetings have happened, and technical committee on common testing facility has.
Anything on land acquisition and all
Yeah,
that
I'll,
is
I'll come
happening?
to that point. The thing is, we have already finalized about testing facility. What are the different categories of testing that are required? What is the investment likely to happen? About 270 crore, and about 270 acres of land for testing track. And finally, what we happened, the cluster committee consolidated all this input, and we came out with a 650 acres of land earmarked between Bidadi industrial area and Harold industrial area on Mysore Road, exclusively for putting up of an EV cluster of world class. And the beauty here is, even at this stage of conceptualization, about 6 companies have expressed their interest in order to take up more than 50% of this, kind of 650 acres. That's the point.
So, Anilji, I would like to bring you here once again. If you look at India in terms of component makers, like Mahesh Babuji said, that India can put itself on global pedestal when it comes to electric three-wheelers. In the same manner, how do you see Indian component makers, making a global space for itself? What would be those area, if you could say?
There are a lot of opportunities for the Indian supplier base. You call it jugaad, but it is frugal engineering. So basically, it's frugal engineering. The frugal engineering mindset, we are one of the best. And we can find solutions in a very cost optimal and time efficient way. And that is one of the key strengths of the Indian supplier base. So here I see a big potential. Second one, the software plays a significant role for electrification. And India is the source of it. So here I see that for the system part, we are already ahead. In fact, you will find many Indians all over the world doing this development elsewhere. So why not from India? So I see that as a potential place where we can contribute significantly. Third one, the learnings from India are very unique because our conditions are different from the rest of the world. So when we're able to master the reliability of the components in India, it can be of worldwide applications. So these are things which I'm telling you practically, which we have done, where the technology has gone from India to the rest of the world.
Jitendra ji, you seem to have some apprehensions in terms of India becoming a volume player, or you to localize you need volume, and for volume you need localization. Probably it's a chicken and egg story. Uh, if we talk about your apprehensions, why you have an apprehensions that India cannot get into a volume of electrification, or why India cannot adopt higher localization when it comes to being a system suppliers for EV ecosystem?
It's not apprehension. I'm telling it is possible. Only the way how it can be done is that we cannot depend only on one technology. Like through two-wheeler, three-wheeler, we have to start towards moving EV mobility. When it comes to the passenger cars, especially private passenger cars, the acceptance of EV is not immediate because the price is high because of the infrastructure. Their low hanging fruit is hybrid electric vehicle. That also has the same component. We can easily localize the component. So I am telling that there is a way to go towards the EV mobility. We can speed up. So we should go for all the technology so that we can do the faster. So there is no apprehension. I don't think that India lack any way to go towards the electrification. Only the way is important.
So it's time for a public poll. I would just please raise your hand if you're in support that hybrid is the low hanging fruit where India can move. Please raise your hand. How many of you think that? Okay, quite a few. How many of you think that we can directly move to electrification? That's the best option. So I think electric, I think, is a larger number of people who think electric vehicle is better option. We have just jumped from BS4 to BS6. Not very huge gap, but marginal only. I'll come to you, Mr. Shashidhar. We have seen one of the cities where we had a major problem with the grid, where the charging stations started bursting. We had a parking bay where we had a couple of cars parked. What kind of precautions, what kind of grid upgradation or smart grid that you're working on to not have such kind of incidents in Bangalore or city in Karnataka?
See, we started this particular 100 locations with 4 already being in service. What we are really, catering to the services is plugging onto the main system and see that particular system that is being installed is all on government premises where a reliable power supply is already being there. Number one. Number two, depending on the kilowatt system or the kind of capacity that is being required by that particular charging station, we strongly suggest and recommend to have it on the 11 kV, not less than that. Okay, so that means an express feeder from the nearest transformer. And if you go by the examples of our protected systems, OA is quality of the entire system starting from the transformer point till the delivery point or the plug point. So all are being standardized, and we are very shortly we are going to notify them also the what kind of including wires, cabling system and all. We're going to standardize them also. And as far as the reliability is concerned, we're going to see that the transformer near to these charging stations are connected to the kind of mainline systems. Okay, and it's a learning curve for us also. We don't say that we have learned everything, but after putting up these 100 stations, once they are by next 15 days they want to be operational, we will learn out of experience. Okay, what kind of precaution measures, improvement and system augmentation that can be done in this.
So with this, I would like to open the floor for questions. You can raise your hand, and Usher can provide you the mic. Yeah. You can also identify the speaker whom you want the answer to come from.
The hybrid vehicle question which you just asked, is the government policy allowing to go for hybrid? Because it is, I heard that it is taxed high. So even though it is a technical solution, what is the policy of government going for hybrid vehicles?
Yeah, a hybrid policy.
You would like to know what is our policy in terms of going for hybrid? Yes, we would like to give them a chance. So that's our decision. Yes. So we are going to give them a chance, and probably we don't put any cap on terms of whether only for 3 years or something. We are giving them a chance in terms of policy, saying that as hybrids are also covered under our policy regime.
Okay, I would just like to add one point. There are 2 points. One is government support with subsidy, government support by policy. And in our view, actually, of course, both are important, but the second one, by policy, is more important. Why I say policy is when the CO2 requirements are becoming more and more stringent, it becomes mandatory for the technology to support that. And that is where the hybrid comes into picture. Example, today, India is at about 130 grams per kilometer right now. The CAFE norms in the next 1.5 years will come down to 113. And the hope is that's where the policy clarity comes. If the next one of 2024 comes closer to 100, I can tell you to get the average fleet efficiency, we will have to move towards hybrids. So there are 2 drivers to hybrids. One is coming from the policy side. Of course, if there is some incentive to push for it, great. Otherwise, the policy will drive it.
So the policy should target on reducing the pollution, CO2, not advocating one single technology or the other technology. That's the larger understanding of the industry, and the policymakers should also consider this. The next question, please. Yeah.
Hello, this is Ashok Kumar from RV Skills in Automotive Electronics. I have two questions. One is why are we not looking for e-cycle for to provide last mile connectivity, which is more affordable, more easy, and which can bring a lot of revolution in the connecting. And even that can be connected to the metro stations directly, where the cycles can go from station to the destination. So number two, which is more interesting, I just want to know the point. See, we are all looking at urban transport. Why are we not looking at rural side? See, India, if you look at India demographically, it's driven by agriculture, population. It's a lot of more villages are there. But nobody speaks about how to provide rural connectivity. There is no last mile connectivity in rural, it's only connectivity. But nobody speaks and no, not much of focus. I just want to ask Mr. Shashikumar, who is heading Karnataka side, probably we can take again lead, Karnataka again take lead, how to electrify even the carts, even the cycles, even the freight transport. See, there's a conventional transport is used, which are mostly by the animals and the low cost this thing. So is there a possibility to provide better, convenient and logistics to rural side? That's a very important one.
I'll split this question into two parts. One is about cycling path. So, DULT, Department of Urban Land Transport in Government of Karnataka, we have earmarked cycling path. So, it's almost getting closed. Once that is done between Koramangala, HSR, BTM layout. So, probably it's a question of cycle path. Now, the thing is, e-bicycles can definitely run on. We have seen the kind of footpaths that are being, carved out in, in Taiwan, and all slow moving bicycles are allowed to move onto the footpaths. Okay, we have seen that success. So definitely, I thank you for that question. And at this particular, pilot project, once it gets succeeded, we can really look at walkable distances can even be traveled by bicycles, or even walkable, kind of pavements. That's also we are very serious. Instead of taking a bicycle, maybe 2 kilometers, anybody can walk, but there are no footpaths for walking. So that's the situation. So the second thing is about rural, connectivity. Definitely, when we look at any of these EV vehicles without battery cost into that, that's the future for India with swapping and leasing model. That's what I'm seriously looking at all the EV manufacturers saying that you just take out your battery part of it, make it cost effective, make it affordable to people, because just now recently they have removed the personal two-wheeler buying subsidy. So once we come out with a model of swapping or leasing of these batteries, I think the penetration, and definitely at that point of time we will definitely put a policy into the framework. Thank you.
Last two questions.
My question is, we were talking about three-wheelers, two-wheelers only. Now, if we just take four-wheelers, wherein in major cities, door-to-door waste collection, garbage collection, wherever municipal is involved, we are using diesel vehicles. If we tend to switch these diesel vehicles to electric vehicles, I think a lot of waste transportation can be done with these electric vehicles, wherein the transportation is only 40 kilometers a day, and we can save a lot of carbon footprint.
Thank you for bringing up again. So we have already circulated an internal, request saying that by next 3 years, 50% of the all government vehicles should go to EV. All governmental multiplexes, private buildings, all parking places should have 20% of the parking slot earmarked for EV. And especially pertaining to your question, all urban bodies for municipal collections, 100% tippers, loaders should go for electric.
That's a great. Yeah, your question. Last question, I think. Yeah.
This is Jitendra here. I think we are all moving to the EV platform. It's good. Hybrid EV, we are all thinking of all these things. We need to think of the initial cost and the return of investment on the customers, the end customers who are going to have that. Are we not thinking sufficiently for the efficiency of what all equipments, all the gadgets, what you're going into the EV? Are we thinking enough on that? because if we don't think, and if this thing goes on and on, nobody will ultimately buy EV, though we are moving ahead on EV, because they will all compare with the diesel and petrol engines vehicles. So we need to think loudly and deeply on the efficiency of various gadgets what we are going to use for the EV. Are we thinking sufficiently on that?
Yeah, thank you. I think that is very, very important because we have to continuously improve the efficiency to get to develop more and more EVs. So, like motor is there, a battery is there, and controller. Not only the energy efficiency, but we have to think that how to recycle that. It is possible to have so many batteries, but finally, how we are going to recycle that? So, how to take the maximum benefit or uses of the battery, like battery can be reused later for the solar power storage, battery how to recycle it, so all.
How to improve the life of the battery?
Yes, and how to improve the life of the battery. So as Toyota, what I can tell you is that last 2 decades there is a lot of research has gone, and almost 400% we have improved the volume efficiency. What was our generation 1 hybrid and what is the generation 4, there is a huge improvement in the efficiency is done, and that is the need of the hour, and it must be done. So completely agree with you.
Hello. My question goes in at a tangent. If somebody could answer that. You see, we are talking of the final product, that is the vehicle. How much of CO2 this thing reduction is there and all that. So every car or vehicle needs its components which are being manufactured elsewhere by somebody else. So have you also taken into account the pollution which is created by the manufacturers of the components? See, because it is very easy to say that the final vehicle gives this much of saving of CO2 and all that. Has a study been made about the components which are to be manufactured, plus the raw material procurement and the raw material generation, how that will cost and how that will produce CO2 and all that, whether any study has been made?
You can also answer later, but I will just tell. When I was speaking, I used the word cradle to grave scenario. So a lot of work has gone to analyze the cradle to grave, that is end to end, which includes the subcomponents, the manufacturing, the assembly, including the disposal. So this is the value chain that comes in the cradle to grave situation, and that's a comparison that's made today between the existing IC engines and tomorrow's EV world and the intermediate technologies. A lot of studies are there, and in fact, in one of our publications, we have a white paper where we have also gone deeper into the values. So it's probably can be shared, but a lot of work is going on in the cradle to grave situation, because at the end of the day, climate is influenced by this, not by the local emissions. It is end to end.
A small question.
So, you want to add?
Definitely, even today, when we talk of solar panels, and we normally say the source of it, whether it has been generated using solar power. So once that closed loop comes into picture, once that cycle gets completed, I think everything will be on a renewable energy in future. So that's what I'm going to say.
Thank you, gentlemen, for such an enriching and detailed discussion. I think we are running out of time, but one question we can take probably last. Yes.
I have a small question.
Yeah.
We were talking about batteries. Now, is supercapacitor being thought of for hybrid? What's this developments and what are the current status?
Supercapacitor in hybrid.
Yeah, that is also one technology which supercapacitor it can store. So it has got definitely its advantages and disadvantages, and it is considered as utilizing supercapacitor for different kind of requirements. So it is thought of.
One last question. In the battery, you are saying that components, various components, positive, negative, is solid state being considered? By
Solid.
Yeah, that is what the future research is happening on the solid state battery, and that is going to be future because that can have a better energy efficiency. So Toyota is also working, and many other players are working in the solid state battery. So that's why battery technology is going to change very rapidly because it has to be more energy efficient, compact, and affordable. So that is definitely going to happen.
I want to leave the audience with one simple question. Van Gang, the father of China electric revolution that happened today. So decades ago, when an ordinary person like me went to the premier of China, said, "I have a dream," then he was given a say over and above. He was not opposed by any of the authorities. That was the level he was given an autonomy, and today he created this revolution in China. What he says is the future is hydrogen fuel cell, and there's a huge lithium ion battery inventory waiting for them to dump into India. My question, just think about it, whether we can start, whether we should start where we stopped, or we should start from where China stopped. That's my question.
That's a very interesting question to ask. With this, I would like to end this very enriching and great discussion. And the audience, you have been really great. The questions you have asked has really added a lot of value to the discussion. Thank you so much for joining ET Auto E Mobility Convention. Thank you so much.